have to believe in a world outside my own mind. I have to believe that my actions still have meaning, even if I can't remember them. I have to believe that when my eyes are closed, the world's still there. Do I believe the world's still there? Is it still out there? Yeah. We all need mirrors to remind ourselves who we are. I'm no different.
I am not an animal! I am a human being!
Particles can have a positive charge or a negative charge. Particles with the same charge repel one another. Particles with opposite charges attract one another. This is because charged particles create electric fields. And electric fields exert a force on charged particles. When there is an electric field between 2 points, we say that there is a voltage between them. Voltage can be thought of as the height of a mountain. Rocks at higher elevations can do more damage. The same is true with voltage. The height of the mountain tells you the energy of each falling rock. The total power is the height of the mountain times the number of falling rocks. Similarly, the voltage is the energy of each charged particle. The total power is the voltage times the number of particles. The number of particles is called the current. In a circuit, the charged particles flow through wires. If the wire is cut, the current stops flowing. All wires have charged particles in them. A battery creates an electric field which pushes the charged particles along. With this setup, if one light bulb breaks, all the lights turn off. With this setup, if one light bulb breaks, the other lights stay on. More batteries will give more voltage. This will cause more current to flow, and the lights will be brighter. The batteries do not create the charged particles. The batteries only create an electric field which pushes the charged particles along. All charged particles create electric fields. However, only moving charged particles create magnetic fields. Magnetic fields exert a force only on other moving charged particles. A charged particle moving in a loop creates a magnetic field that looks like this. A spinning electric charge is the same thing. When a material has many charged particles spinning in the same direction, we call it a magnet. We call one end of the magnet the North Pole and the other end of the magnet the South Pole. The magnetic fields exert a force on the spinning charged particles in other magnets. Magnetic fields can also be created by current through a wire. Reversing the direction of the current causes the magnetic field to reverse direction. By constantly changing the direction of the current, we can cause the magnet to rotate. This is how electric motors are made. All charged particles create electric fields. And electric fields exert a force on charged particles. Only moving charged particles create magnetic fields. Electric fields can also be created by a magnetic field which is changing with time. A moving magnet creates a changing magnetic field. The changing magnetic field creates an electric field which pushes the charged particles. The magnet must keep moving to maintain a changing magnetic field. The changing magnetic field creates an electric field which pushes the charged particles. The magnet must keep moving to maintain a changing magnetic field. This can be done by rotating the magnet. This is how power plants generate electricity. Here, the voltage and current keep alternating direction, so we call this AC voltage and AC current. AC stands for alternating current. A battery creates a voltage and a current which is always in the same direction. So we call this DC voltage and DC current. DC stands for direct current. All charged particles create electric fields. However, only moving charged particles create magnetic fields. Electric fields can also be created by a magnetic field that changes with time. Similarly, an electric field changing with time can create a magnetic field. Since changing magnetic fields create electric fields and changing electric fields create magnetic fields, this can cause a chain reaction. We call this an electromagnetic wave. This is how radios and cell phones communicate. Visible light is also an electromagnetic wave. The only difference is that visible light has a much higher frequency than radio waves. Each color is a slightly different frequency. Electromagnetic waves with much higher frequencies are called X-rays and gamma rays.
some science buddies, and this video will provide a brief introduction to magnets. If you've ever played with magnets, you've probably noticed that you can use them to pick up metal materials, but not other materials like rubber, wood, styrofoam, or paper. This is because certain metals, primarily iron, nickel, and cobalt, have magnetic properties, but it's important to remember that not all metals are magnetic. For example, here on the right, most of the coins are actually made of copper, so along with this piece of copper wire, the magnet actually cannot pick them up, while it can easily pick up the paper clips and screws which contain high amounts of iron. Every magnet has two poles, a north pole and a south pole. When you bring two magnets close together, the opposite poles will attract or pull each other together. Here you can see a north and south pole pulling each other together. If you bring two similar poles, meaning two north or two south poles together, they will push each other apart. Here you can see one magnet pushing another magnet away without actually touching it, as two north poles are brought close together. If you flip the magnet around, the south pole will attract the north pole. You can do the same thing, starting out with two south poles, which you can see here will repel each other just like the two north poles did. You can push the magnet without touching it, and then if you flip it around, the north pole will attract the south pole. Magnets can push or pull on each other because every magnet is surrounded by an invisible magnetic field. We represent the magnetic field with magnetic field lines that you can see here. Remember that every magnet has a north pole and a south pole. The magnetic field lines point from the north pole to the south pole, and the magnetic field is strongest where these lines are bunched closely together. Even though a magnetic field is invisible and you can't see it, it can still create a force on other magnetic objects. You can detect it using a compass. A compass is a small bar magnet that is mounted on a pivot and is free to rotate. When there are no other magnets nearby, the compass will always align in the same direction. This is because the Earth actually has its own magnetic field. So, since the compass is a magnet, it will align with the Earth's magnetic field when there are no other magnets nearby to disturb it. However, if you bring another magnet nearby, its magnetic field can override the Earth's magnetic field and affect the direction that the compass points. Now, watch what happens when I bring the compass close to a magnet. You'll notice that the white part of the compass needle is always attracted to the magnet's south pole, and the red part of the compass needle is always attracted to the magnet's north pole. Remember that this is because the compass itself is a magnet with north and south poles, and that opposite poles attract. The compass always aligns with the direction of the nearby magnetic field. You can see that in this image where each compass is aligned in a different direction depending on its location. This is because the magnetic field lines curve around the magnet as you saw in the previous image, and each compass lines up with the magnetic field lines at its particular location.
want to show you. Walk straight ahead to the alleyway. Don't turn around. Be sure that all the lights downstairs are out.
But Dr. Laird, can people do anything to avoid tension? Yes. Naked, making love all the time.
All representatives are currently assisting other customers. Your call is important to us, so please hold for the next available representative. Thank you. All representatives are currently assisting other customers. Your call is important to us, so please hold for the next available representative. Thank you.